Hello and welcome to Nine Cuts. My name is Salino and I'll be walking through with you solving algebraic equations. So now, what does it truly mean to solve an equation? Take for example 3 plus x divided by 2 is equal to 5. Now, this is a two-step equation, and we will be covering that in a future video. But for now, this is an example, and what it means to solve is to get the variable alone. So x has to be alone with the rest of the equation on the other side. So you see what I did here, I isolated x, and I put the rest of the digits in the other side of the equation. So I rearranged the equation to put the known numbers on one side and the unknown numbers on the other side. So now solving equations doesn't mean that you can just use the inverse operation. Yes, you need to. So if you need to solve something like x plus 3, you subtract 3. But not only from one side, you subtract it from both sides. The reason is we need to keep the equation in balance. So think of algebraic equations as scales, balance scales. So the equation will remain in balance if both sides are equal. So let's say 1 plus 1 is equal to 2. So now this equation is balanced because 1 plus 1 is equal to 2. But what if we change it up for a bit? Like, what if we change it to just 1 is equal to 2? Now, this would no longer be in balance and thus be not true. So, let us try an example. Let's try with addition and subtraction. So, let's say we are given the question x plus 5 is equal to 7. Now, to find this, all we have to do is subtract 5 from both sides. Why, you ask, is we need to exterminate, if you'd say, 5 from this side of the equation because we need to isolate x. So once this is finished, we will get x is equal to 7 minus 5, which you guys know is 2, and so we will get x is equal to 2. This is our finished product, and it is because we have rearranged the equation to leave x isolated on one side of the equation. So let's try with subtraction. So what if it was y minus 3 is equal to 8? How would we solve this? We can no longer subtract 3 anymore. Oh no, that would just lead to even further negative. So that would lead to -6. But to isolate y, we can use the inverse operation of this, which is addition. So we add 3 to both sides to keep it balanced. So we add 3 to this side, these two cancel out, and we will get y. And on this side, 8 plus 3 is equal to 11. So here our finished product was 11. See, that's not so bad, is it? So let's try something with multiplication and division. So with multiplication, we can try x multiplied by 3 is equal to 27. So now to solve this, we can't really add or subtract 3 to both sides because the symbol is multiplication. So we have to use the inverse operation of that, which is division. So we divide both sides by 3. And these two will cancel out because it's multiplication and division. So we will get, after that is x is equal to 27 divided by 3, which you know as, if you know your multiplication tables, as 9. So our finished product is x is equal to 9. That wasn't so bad. So let's try division. It's not as hard as it sounds. So let's try y divided by 5 is equal to 5. So we can't divide here again because it will lead to negative. So we can try to multiply 5 to both sides because that's the inverse operation. So when we multiply 5, these two will cancel out, leaving us with only y. And now remember, we need to multiply to both sides, and we will get 5 times 5 is equal to 25. So our finished product is y is equal to 25. See, solving algebraic equations is easy, especially the one-step ones. The one-step ones equations are the ones that we did right now, and they only require you to use the inverse operation to undo them. So we use the inverse operation to undo that operation. Thank you.